To start our discussion of trigonometry, we're going to look at the unit circle given by this equation, x squared plus y squared is equal to 1. If you graph this, you get this circle centered at the origin with a radius of 1. We can draw angles on this circle and use that to define something called sine and cosine. The way that we draw angles on the circle is with the following convention. One side of your angle is going to be on the positive x-axis. We're going to rotate counterclockwise to create a positive angle. So maybe we'll rotate maybe to like, somewhere around like here. So I rotate to this spot and I connect this line to the origin to create this angle, which I'm going to call theta. And the thing to point out is that we get this point on the unit circle that has an x-coordinate and a y-coordinate. Now that takes us to our definition of sine and cosine. So sine of the angle, so this will be abbreviated sine of theta, this is actually equal to the y value of that coordinate. Cosine, which is abbreviated cos, and then theta is the x value. So that's it. That is what is meant by sine of theta and cosine of theta. You start on the positive x-axis, you rotate some amount to create an angle theta, you get a point on the unit circle, that point has an x and a y coordinate, we call this coordinate cosine, and we call this coordinate sine. Now, one other thing before moving on is, this equation gives us a very fundamental identity, and it's this one. I stated before that, well, sine squared of theta plus cosine squared of theta is equal to 1. This is called a Pythagorean identity. Where does this come from? It comes from directly plugging in cosine for x and sine for y into the equation of the circle. I mean, that is how we're defining x and y, so we're just replacing them with sines and cosines. So it would look something like this. You take your equation for the circle. Oh, x is equal to cosine of theta, so we'll just put that in place of x. We will put sine of theta in place of y. And it's customary to write cosine theta squared as cosine squared theta. Same thing for sine of theta squared. And we just reverse the order of the sines and the cosines to get this identity. So there are a ton of identities when studying trigonometry. This is a very fundamental and important one, and it comes directly from how sine and cosine are defined. Now that we have defined sine and cosine, we can actually use it to evaluate sine and cosine at some particular angles. So here I have some angles listed in degrees. I'm going to draw them on this unit circle, and we're going to think about what the values of sine and cosine are. So I'll put a line for sine of theta and a line for cosine of theta. And we'll start with 0 degrees and evaluate sine and cosine for this angle. What does it mean to be 0 degrees on this circle? So we're starting at the positive x-axis, and we have this point here at 1 for x and 0 for y. A 0 degree angle means you have not rotated, so you're right here. So this is the location of 0 degrees, and it has the corresponding point 1 for x and 0 for y. Said another way, the x value 1 is what we call cosine, so cosine of 0 degrees is 1. Likewise, sine is the y value, so sine of 0 degrees is 0. When trying to figure out values for sine and cosine, it's nice to think about the unit circle because you can locate x and y coordinates on it. All right, what about 90 degrees? A 90 degree rotation is going to here to create a right angle. So this point right here is the point, okay, that is 0 for x and 1 for y. That creates a 90 degree angle. And that means sine of 90 degrees is 1. And cosine of 90 degrees is 0. Again, that's the x coordinate for cosine and the y coordinate for sine. All right, well, what about 180 degrees? So that's going 90 twice, that's half a full rotation. So that's going to be over here. So let's see, that is 180 degrees. It's corresponding to the point -1, 0. Okay, so cosine is going to be the x value, so I get -1. And sine is going to be the y value, which is 0. Maybe I'll label up here that this is also 90 degrees. All right, 270. Okay, that's going to be another 90-degree rotation. So that is right here. Okay, so this is going 270 degrees, and it's at the point 0 for x and -1 for y. Those, again, are the x and the y coordinates. So it's going to be -1 for sine and 0 for cosine. So that was 0, 90, 180, 270, and then if you go another 90, you're back where you started. So the location of 0 degrees and 360 degrees is the same exact spot. So the values that we have here for sine and cosine are exactly what we'll have over here. 0 and 1. That's why sine and cosine are periodic with a period of 2 pi. This thing that starts repeating over and over again with every single rotation. I'll add on to here that you can have a negative rotation as well, and the convention is the negative sign means you're just going backwards instead of going this way. So that is, we're going clockwise instead of counterclockwise. So -90 is going backwards 90 degrees. It's the same location as positive 270 degrees. So let's put a comma here and say, well, this is the same location as -90. And if you want to know sine and cosine, again, that's the x and the y values. Therefore, sine of -90 is -1. Cosine is 0. What about -180 degrees? Okay, so that's going backwards half a rotation. That's actually the same spot as positive 180 degrees. So again, the x-coordinate is cosine and the y-coordinate is sine. So we get the following values. We get that cosine is equal to -1 and sine is equal to 0. So these are getting the values of sine and cosine for these angles directly from the definition of the unit circle. There is another unit that you can use to measure angles instead of degrees, and that's something called radians. We're going to be using that primarily in this class. It works in a similar way where you start by rotating on the positive x-axis. So you would start by rotating here, and you would also go in the counterclockwise direction for a positive angle. But the difference is we're going to use the circumference of this circle as a guide to tell us how far we actually rotated. So here's going to be rotating 0 radians. And you can put an R, A, D after it just to indicate the units are different than degrees. Since this is a circle of radius 1, and the circumference of a circle is given by 2 pi r, if you put 1 in place of the radius, you're left with the circumference is 2 pi. So traveling around the circle is going a distance of 2 pi, and so we'll say a full rotation is something called 2 pi radians. So it's a little different, but instead of saying 360 degrees, we're saying if you do a full rotation, you've gone 2 pi radians. Again, this is trying to connect it to an actual distance that you travel by going around a unit circle. So it's actually like a important connection here, is that if you go 360 degrees, that's the same thing as saying you've traveled 2 pi radians, or that's how far you've rotated, I should say. This thing. Anyway, with this new angle measurement, you can still think about what sine and cosine are equal to for these radian measurements. Well, to start with, if this is 0 radians, we're still talking about this point here that has an x-coordinate of 1 and a y-coordinate of 0. So sine and cosine are, again, the x and the y value. Sine of 0 radians is 0, and cosine of 0 radians is 1. All right. Well, what about this? Radian measurements are going to have a pi attached into it, or often they'll have a, some number or some negative value times pi. So like, where's pi over 2? Where is pi? If a full rotation is 2 pi, that would mean half of a rotation is this number divided by 2. So half a rotation is pi radians. If you go half a rotation of pi radians, that would be pi over 2 radians. So it is strange, but it's using a similar logic. A full rotation is 2 pi, therefore half of it would be half as much, which is pi. If half a rotation is pi, then half of that is going to be pi over 2. I'll also label that this is 3 pi over 2. So if you start pi and go backwards pi over 2, you're at pi over 2. If you're at pi and you go forwards pi over 2, you're at 3 pi over 2. All right, so let's use these measurements to get the values of sine and cosine for these points. So for pi over 2, which is 90 degrees, the x-coordinate is 0 and the y-coordinate is 1, and therefore sine of pi over 2 is 1, and cosine of pi over 2 is 0. If you look at the pi radians angle, that has an x-coordinate of -1 and a y-coordinate of 0, and therefore sine of pi is 0 and cosine of pi is -1. If we go to 3 pi over 2, all right, so this one here has an x-coordinate of 0 and a y-coordinate of -1. Therefore, we have that sine of 3 pi over 2 is -1, and cosine of 3 pi over 2 is 0. And then once you get back to 2 pi, you're saying you've gone a full rotation, so we get the same values again. Sine of 2 pi is going to be 0, and cosine of 2 pi is going to be 1. I put these last two on here just to indicate that the convention of a negative angle means you're rotating clockwise as opposed to counterclockwise. So the location of negative pi over 2 is right here. It's actually at the same location as positive 3 pi over 2. And this means that cosine and sine are defined by the x and the y values there. So sine of negative pi over 2 is -1, and cosine of negative pi over 2 is 0. Where's negative pi for this last part of the example? That's going half a rotation in this direction. It's actually at the same location as pi. So this is also negative pi. Therefore, sine of negative pi is 0, and cosine of negative pi is -1. I put this connection up here between degrees and radians. You could divide both sides by 2 in this relationship to get a simpler one. It's more often stated that, half a rotation of 180 degrees is the same thing as a rotation of pi radians. Either one's fine, but that is it for radian measurements. So we've looked at angle measurements that always fell on an axis, like 0 degrees, 90 degrees, 180 degrees. But there are 3 important reference angles I'd like to add into the list, which is 30 degrees, 45 degrees, and 60 degrees. So I want to know what sine and cosine are for these values. They're going to be very important, and we'll refer to them often. I'm going to start by drawing a 30-degree angle approximately on this circle down here. So maybe that's like, here. This is a 30-degree rotation, which is equal to pi over 6 radians. So if you want to know sine and cosine, you'd have to know the x and the y coordinate. I'm just going to state what these are equal to. Sine at this angle is equal to 1/2, and cosine is equal to √3 over 2. Now, the way I drew it, the y coordinate here does appear to be halfway through. This √3 over 2, it's pretty close to 1. I'm not justifying why these are true. We're just going to use these values as we move on. If you want a 45-degree angle, okay, so that's like roughly here. So this is 45 degrees, which is equal to pi over 4. So I'm just going to state the exact values for sine and cosine here. It's the square root of 2 over 2 for both of them. Sine and cosine are actually the same thing. It's the same x and y value on this line, and that makes sense. Now, if you move over to 60 degrees, so that's like right about there. This is a 60-degree angle, and in radians, that's pi over 6. The corresponding values for sine and cosine are, it's root 3 over 2 for sine and 1/2 for cosine. It's good to know these and probably even commit them to memory. I think one thing to make it easier to know that there is less stuff to memorize, if you know the values for sine, the values for cosine are just listed backwards. So like this 1/2 corresponds to this 1/2. These two are the same. This is equal to that. And also I just note that, well, sine of a 30-degree angle, the y value is about 1/2, and that helps me remember it. There are other trig functions besides sine and cosine, so I'm going to list those down as well, and then write down what their reference angles equal at 30 degrees, 45 degrees, and 60 degrees. For starters, there's tangent, there is cosecant, there is secant, and then there is cotangent. Between these four and sine and cosine, these are the 6 main trig functions. These are all defined off of sine and cosine. So for example, tangent by definition is the ratio of sine and cosine. Cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. And cotangent is the reciprocal of tangent, but we'll write that as cosine over sine, basically flipping this fraction. So I'll write out the values for tangent, cosecant, secant, and cotangent for these reference angles, and then you can just verify them by using the values for sine and cosine. But for tangent of 30 degrees, that's equal to the square root of 3 over 3. Tangent of 45 is equal to 1. And tangent of 60 is equal to the square root of 3. For cosecant, cosecant of 30 degrees is 2. For 45 degrees, it's the square root of 2. And then for 60 degrees, it's 2 root 3 over 3. For secant, we get 2 root 3 over 3. We get the square root of 2. And then we get 2. And then for cotangent, okay, so for this one here, we get the square root of 3, we get 1, and then we get root 3 over 3. So if you'd like some practice using these definitions, you can use sine and cosine to figure out all of these values. Let's now use the unit circle and some reference angles to figure out values like, let's say, sine of 3 pi over 4. All right, for starters, if I see a problem like this, I try to think of, is there a reference angle that will help me answer what this is equal to? I see a denominator of 4, in fact, for all of these, that immediately makes me think of the reference angle pi over 4, which is 45 degrees. I'm going to draw that on the unit circle. So that's something like this. Here's pi over 4 radians, and that's 45 degrees. By the way, we also know that sine of pi over 4 is equal to root 2 over 2. And that is the y value. It's the y value of this point. All right, great. But how does that help me figure out sine of 3 pi over 4? I want to locate where is 3 pi over 4 on this unit circle. Where is it? Well, if you're counting by pi over 4s, this is 1 pi over 4. This is 2 pi over 4, another 45-degree angle. And therefore, if you go another 45 degrees, over here, this is 3 pi over 4. Let me draw that in. So here is 3 pi over 4. A lot of ways to think about it. You can think about counting by pi over 4s, and this is just the third one over. Another way to think about it is, I know this is pi radians, right? Over here is pi radians. And that's equivalent to 4 pi over 4, right? If you cancel the 4s, it would give you just pi back. So if you went backwards pi over 4, it would drop down from 4 pi over 4 to 3 pi over 4. Now, why is this helpful? Now, I don't think I drew this perfectly, but these 2 points have the same y value. And the y value is what we're calling sine. So sine of 3 pi over 4, the y value here, is equal to sine of pi over 4, the y value here. So another way, sine of 3 pi over 4 is also equal to the square root of 2 over 2. And the reason for that is that the y value here equals the y value here, and we got this from a reference angle. Okay, so what about cosine of 3 pi over 4? By the way, we stated before that, well, cosine of pi over 4, okay, that's it's also positive root 2 over 2. But how does the x-coordinate cosine of this point help me with the x-coordinate of this point? They're definitely not equal. But the x value here is going to be the negative of the x value there. So what does this mean? It means that, well, the x values aren't equal, but they're opposite in sign. Because cosine of pi over 4 is root 2 over 2, that means cosine of 3 pi over 4 is negative root 2 over 2. It's a very fancy way of saying it's just not the positive x value, but it's the negative one. So when answering questions like this, the answer is either going to be equal to your reference angle, or it's just going to be off by a negative, depending on where it is on the unit circle. So great, but what about sine of 5 pi over 4? How do I figure that one out? Same process. I see there's a 4 in the denominator. It's making me think of this as my reference angle. I'm just going to try to locate where 5 pi over 4 is on the unit circle, and then somehow connect the x and y coordinates of that point to the x and y coordinates of this point. By the same logic, if this is 4 pi over 4 and backwards pi over 4 is 3 pi over 4, then going forwards pi over 4 would be 5 pi over 4. So here's the location of 5 pi over 4. All right, so how's that help me figure out what sine of 5 pi over 4 is equal to? Well, I know that the y-coordinate here, it's not equal to the y-coordinate of this point, but it is in fact the negative of it. So it's like down here. That means if I want to know sine of 5 pi over 4, it's not equal to root 2 over 2, but it's equal to the negative of it. And the reason is because the y value is negative instead of positive. Okay, cosine of 7 pi over 4. So where is 7 pi over 4? That's the question. Well, a couple ways to think about this. You could say, okay, I'll count by pi over 4 to 6 pi over 4, and then one more time to 7 pi over 4. That's completely valid. So here's 7 pi over 4. Or if you wanted, I know a full rotation is 2 pi. So right here, if you went to this spot, you've gone a distance, an angle measurement of 2 pi. That's the same thing as 8 pi over 4, right? Because 4 goes into 8 twice. And if this is 2 pi and you go backwards pi over 4, subtracting 1 would take you from 8 down to 7. A couple ways to think about it. Either is fine. Okay. So if you want to know cosine of 7 pi over 4, it should relate somehow to cosine of pi over 4. I see that these two things have the same x value. Therefore, cosine of 7 pi over 4, the x value here, is equal to cosine of 7 pi over 4, the x value here. So therefore, the answer is positive, root 2 over 2. So no surprise here. The answers relate back to the reference angle. It's just that some are positive and some are negative. All right, last one. What about sine of negative pi over 4? Where's that? That would mean you'd start here at 0, and you go backwards pi over 4. It's actually right here. This location is also negative pi over 4. And we want to know, well, what's the y value of this point? It's going to be the negative of the y value of this point. So I won't use positive root 2 over 2. Instead, I'll use negative root 2 over 2. So here we go. We evaluated several trig functions at different angles by using a reference angle and understanding what is happening on the unit circle. In example 2, I want to do the same thing that we did in example 1, just using some different angles for practice. All right, so for starters, what is sine of 5 pi over 6? I'm seeing this 6 in the denominator, so it's immediately making me think, all right, well, maybe I'll use pi over 6 as my reference angle, which is 30 degrees. So where is that? I'll try to draw it in. It's about, something like this. Here is pi over 6, or 30 degrees. And I know that sine of pi over 6 is a half. It is the y value of this point. So if you want to know sine of 5 pi over 6, step 1 is, well, where is 5 pi over 6 on the unit circle? And then how does the y value relate to this point? It's either going to be equal or it'll be off by a negative. Here's how I'm going to think about it. I know this is pi, or 6 pi over 6. So if I rotate backwards pi over 6, it'll take me to 5 pi over 6. So this is the location of, I'll draw it in, 5 pi over 6, like right about there. Fantastic. What does that mean about sine of this angle? It's the y value, which equals the y value here. So the answer is, it's a half. So 1/2 is the answer to sine of 5 pi over 6. Great. Next, a cosine of 7 pi over 6. Okay, again, I'm seeing 6 will work as my reference angle. Maybe I should write down, okay, well, I know cosine of pi over 6 is equal to, well, that's different. That's root 3 over 2. So the x-coordinate here is root 3 over 2. But where is 7 pi over 6 as an angle? If this is pi, or 6 pi over 6, and you go pi over 6 more, that's going to be 7 pi over 6. So I'll draw that in here. So there's 7 pi over 6. The x-coordinate at this spot must be the negative of the x-coordinate in this spot. And since cosine is the x-coordinate, it means that cosine of 7 pi over 6, it's not positive root 3 over 2, but it's negative root 3 over 2. Okay, for the next one, here we're using a different trig function, secant. That was the reciprocal of cosine. And here we have an angle of 13 pi over 6. I guess step 1 is going to be, well, where's 13 pi over 6? Here's how I would think about it. One full rotation, that's a distance, a degree measurement of 2 pi, which is the same thing as 12 pi over 6, because 6 goes into 12 with 2 left over. So if this is a rotation of 12 pi over 6, and you go pi over 6 more, that would be 13 pi over 6, which is actually right here. So it's the same location as this pi over 6. This is actually nice. If I know the value of secant of pi over 6, it's going to be equal to the value of secant of 13 pi over 6 because we're actually talking about the same location. So what was the value of secant of pi over 6? Well, it is the reciprocal of cosine, but I think that we saw that this was 2 root 3 over 3. And therefore, since we're in the same exact spot, secant of 13 pi over 6 must be equal to secant of pi over 6, so they actually take on the same value. So I'll put down that this is 2 root 3 over 3. And now that takes us to this last one here. What is cosecant of negative 2 pi over 6? You could think of this as using the reference angle of pi over 6, but I'm noticing this 2 cancels into this 6. I think it would actually be better to think about what is cosecant of negative pi over 3. So here we're using a different reference angle, and it's simplified. So my reference angle this time is going to be pi over 3. If I draw that on the unit circle, that's roughly here. So let me draw in my angle of pi over 3. And negative pi over 3 means I rotate not up, but down here. So this is an angle measurement of negative pi over 3. Okay, but how do I actually figure out what cosecant is at this new angle? To start with, cosecant of, and if we look at pi over 3, that was equal to 2 root 3 over 3. It's the reciprocal of sine. Now, sine, it's negative down here. So it must be that since we're really referring to a y value, since we're talking about the reciprocal of sine, it's got to be the negative of the number that we have here. And therefore, the answer to this part is going to be not positive, but negative 2 root 3 over 3. So the thing I'm using to reason this out is, when I see cosecant, I'm really thinking, I know it's the reciprocal of sine. So therefore, if sine is negative down here, well then its reciprocal would have to be negative as well.